Welcome to another episode of Earth is Our Home with Dr. Thomas Blaine. We're going to be looking at La Nina and how it rules the roost in the 21st century. So stay tuned. Welcome to another episode of Earth is Our Home with Dr. Thomas Blaine. Dr. Thomas Blaine is an associate professor with the Ohio State University Extension Program. And today we're going to be looking at a second part to La Nina and how it rules the roost in the 21st century. Tom, it's always a pleasure talking with you.
It's great to be here, Patrick, and I'm really glad to be doing this topic because the cycle of El Nino and La Nina, which is called the Southern Oscillation, has enormous impact for the weather patterns we see throughout the world. And right now, there are some things happening throughout the world that are being blamed on other things, and I don't think that should be the case. I think that what we're going to see here is in the cycle of El Nino and La Nina is that in recent years and decades, La Nina has, as I say, ruled the roost. There's been a lot more La Nina activity than El Nino. And this is not just a technicality. It has a lot of real world implications. And some of those are being misinterpreted by the general public and by the media. And I don't think the scientific community has done a good enough job in explaining to the media or to the public what these effects are. So that's why I'm doing this 3-part series to explain very carefully to people so they get an understanding of this.
Well, I appreciate what you're doing. You know, when you hear La Nina, El Nino, first of all, we sort of get confused which is better. Even those words tend to confuse most of us, and we really don't understand how it affects the atmosphere.
Well, hopefully, I'll explain that pretty clearly in this series. So if we can get started, El Nino's kind of disappeared in recent years, leaving La Nina. Now, again, what this has done is there's been a lot of speculation and misinformation. You look at the temperature trends from the satellite data, and a lot of people who are denying that global warming is happening claim there's been a pause in global warming over the past 24 to 25 years. And that's just not true. But there are some things in the temperature data that make it look like that could be true, but those things are caused by La Nina. Another topic that's come up, especially in the last year, is the focus on extreme weather events, especially the drought in the southwestern United States, California, Nevada. Everything's burning up out there. And again, a lot of people are blaming that on the other side on global warming. And I don't think global warming is the culprit there. I think La Nina is what is doing that. And so we're going to get to that here. In other words, the root of both the slowing of the rate of increase in global temperatures and the freakish weather events we're getting. The cause of both of these is La Nina, which has been a lot more common in the past 24 to 25 years than it was in the previous. If we look here again, it's just a map that centers around the equatorial Pacific Ocean. We see there's cold water off the coast of South America because the current brings that water up off the coast of Antarctica. There's a counterclockwise flow in the oceans in the southern hemisphere. that cold water reaches the equator. And even though you're at the equator there off the coast of South America, the water's quite cold. Then as it moves across, driven by the trade winds, the longer it's near the equator, the warmer it gets. And by the time it gets out into the western equatorial Pacific, it's extremely warm water, very warm water. So your climate out there tends to be hot and humid in the western Pacific. That's kind of the normal flow. And we've talked about that. You can go back and watch part 1. We'll put that down at the bottom if you missed part 1, why those winds blow that way. They're called the trade winds. And if you look in North America with this set of conditions, you see the polar jet stream, which separates the air that's very cold over the North Pole from the temperate zone, our zone, the United States, Ohio and so forth. And then the subtropical jet is on down below that. And that's where you run into the tropical weather conditions, climate conditions. Now, La Nina is really an exaggeration of this somewhat normal condition. Imagine you ramp up the trade winds, you ramp them up. And so that water coming off the Americas at the equator and the Pacific, it moves out there at a stronger rate. It's being pushed, the water's being driven by very strong winds that are blowing from east to west. That cools down the equatorial Pacific Ocean. And you only get a very small amount of warm water way out at Indonesia and the Philippines. That is La Nina. That's a classic La Nina right there. Very cold water. And there's what we see when we look on a map without all the wind charts and everything. Blue is below average water temps. And just look at the immense size of that huge blue area in the equatorial Pacific. Very cold water. That is La Nina. And because the Pacific is so huge, you can't have this without changing the climate patterns, the weather patterns throughout the world.
Since the ocean depth is so large, in certain places,
Yes.
when you talk about warming of the waters, are we talking like 100 feet, 1,000 feet? What are we talking about?
Yes, these are surface temps. If you look down there, we didn't go over this, but I'm glad you asked it. If you look at near the bottom, it shows a thermocline and upwelling. So what happens in the ocean, Patrick, is as you go down deeper, pretty much anywhere in any deep ocean, the water gets colder naturally, even if you go to an area where the water's warm. Like if you look out there in the Western Pacific, if you go down deep, the water there's never exposed to the sun. And because of that, deep water, where you get down deep, you take your thermometers and you lower them down into the water, you'll find that the water temperature tends to decline as you go down. And so when we talk about El Nino and La Nina, though, we're talking about temperatures on the surface. And when you say the surface, how deep is the surface? We're not talking about, a mile or anything like that in depth, but we are talking about quite a number of feet, because what's happening is as the wind blows, it's shearing the top off of the water. And it actually tends to be, when you get a La Nina like this, the sea level out there in the Western Pacific is actually about 3 feet higher than the sea level off the coast of America, of the Americas. So think in terms of the surface as a number of feet, maybe 10, 20, 30, 40, 50 feet deep when we're talking about El Nino and La Nina. You know, when you look at something like this, these are temperatures at the surface which would generally be the top 40 or 50 feet of water, because that's the water that eventually really gets exposed to the surface. And when you get cold water like this, yes, there are upwellings. That cold water then comes to the surface, interacts with the air, and cools the air down. And so that's why La Nina cools the whole planet by like a whole degree Fahrenheit. Imagine you're measuring the temperature of all of planet Earth's atmosphere, and you get a 1 degree cooling. That's a lot of energy. That's an enormous amount. It might not sound like a lot, but 1 degree Fahrenheit multiplied by all areas on the planet, that's a lot of energy it takes to cool that down. So it's a matter of feet, even though the oceans are, you know, miles deep, literally. There are a lot of places where the ocean is miles deep. We're not talking about, when we talk about these currents, we're talking about surface currents. Now, there are deep ocean currents too, but that circulation is cut off from surface circulation. So we're talking here about surface circulation. So thanks for that question, because that's very important.
You had mentioned something, you know, that the surface of the water interacts with the atmosphere.
Yes.
And so that gives us different sets of winds, right?
Yes. And temperature and condensation, which changes rainfall patterns. Everything you can think of, humidity, low pressure, high pressure, wind patterns, it changes everything. Just a few degrees difference in the surface of the equatorial Pacific changes a lot, as we'll see. Now, when those winds reverse and you go against the trade winds and you bring warm water from the Western Pacific back to the Americas, that's El Nino. So La Nina is what we're talking about today, the southern. And when you talked about, you know, El Nino means the little boy, La Nina means girl. They got this name because fishermen off the coast of South America, who are Spanish speakers, they noticed decades and decades ago that sometimes they would go out fishing and the water would be unusually warm. They didn't really understand why, but sometimes this would happen near Christmas. In December, they just noticed it happen. El Nino is not more common in December. It just so happens that that's when they really noticed it. And of course, El Nino means the little boy. And in Spanish, a lot of times they refer to the Christ child as El Nino. So they discovered this in December, that a few Decembers in a row, I guess, there were warm waters out there. And so they christened it El Nino for the Christ child. And over many decades, as scientists began studying this, they discovered that sometimes it's colder than normal. And so they stuck with the name El Nino for the warm water. And they said, okay, we'll call the cold, La Nina. And that's how you get the names. And the thing about it is the two together are called the Southern Oscillation, that back and forth. Now I want you to see the La Nina pattern in North America and look what it does. For one thing, look at that enormous, absolutely enormous dome of cold air that just comes down all the way from the pole and makes Alaska colder than normal, most of Western Canada. That's a pretty huge area. It comes all the way down into the northern Great Plains, that cold air does. It cools down the Dakotas, Nebraska, Montana, Minnesota, the northern plains. This cools the temperature of planet Earth overall. This is part of the pattern of how La Nina cools planet Earth by changing the jet stream there and bringing it down. Notice that we've had a pretty wet year so far. Here in Ohio in June of 22, we've had a very wet year so far, lots of precipitation. And that's what you would expect in La Nina. You can see where it says wetter over Ohio and basically the eastern portion of the Great Plains. But notice in the Southwest, as you know, California is undergoing a severe drought, as is Nevada, Utah, Arizona. Those are dry places anyway. But the drought they're experiencing now, the Colorado River is drying up, Lake Mead is drying up. But that's what we would expect in La Nina. I did a check the other night on Portland, Oregon. And Portland, Oregon has been pretty wet. So there's a dividing line out there between where it's wetter and where it's drier in La Nina. And unfortunately for California, where a lot of our crops and produce are grown, the drier region during La Nina is very substantial. Now, here on the other hand is El Nino. Notice what happens in El Nino. First of all, El Nino warms the planet by over 1 degree Fahrenheit a lot of times. Imagine 1 degree Fahrenheit. And if the trend we're on, that's like 40 years of global warming that can happen in just a few months if we get an El Nino. And you see the vast area. That's a huge area. Most of Alaska, almost all of Western Canada, way down into the northern plains, a huge area of warmer weather with El Nino. But notice we can get drought in El Nino here in the eastern Great Plains. But what I want you to look at is California and Nevada and those places in the Southwest. El Nino tends to bring a lot of rain out there. It tends to get wet out there. We haven't seen El Nino in a while. Where did El Nino go? And isn't it true that the drought that we're seeing in the Southwest is being caused by La Nina? Here's another look at it. Again, Patrick, look at the La Nina on the left and look down there where it says dry. D-R-Y. The Southwest is dry in La Nina. It's wet in El Nino because the jet stream comes right through there. And the jet stream tends to carry storms. Storms tend to ride on the jet stream. So when the jet stream runs through California and so forth, they get quite a lot of moisture. But that doesn't happen in La Nina. The jet stream is to the north and the subtropical jet joins forces with the polar jet in La Nina, and that keeps water, rain, precipitation, snow away from the southwest. And that's the pattern we're in now. So these are the tendencies. La Nina brings cold air over large portions of North America and causes dry conditions in the southwestern United States. Now, Patrick, have a look at the Drought Monitor. That's this month, June of 2022. This is the situation that has been making news. But doesn't this look to you? Because it looks to me just like the classic textbook La Nina. Look at all that drought in the southwest, much of Texas, New Mexico, portions of Arizona, then Utah, Nevada. Look around Las Vegas and southern Nevada. Lake Mead is drying up. Look at California, but look at Washington and Oregon. Look at Washington and Oregon. Let's go back and have a look at that. You see Washington and Oregon? On the La Nina, the jet stream comes through there. And look at that. You can get a lot of precip in Washington and Oregon. And you can see much of Washington and Oregon is immune from the drought. Now, portions of the drought have extended up into Oregon, but for the most part, Oregon, it's nothing like the Southwest. To me, this has this has La Nina written all over it. Now look at the Drought Monitor back in 2017, about the same time of year, 5 years ago. The United States was normal. We didn't have drought. Okay, there was a little spot in Florida, but basically what we're saying is in the spring, late spring of 2017, we had quite a lot of moisture. Okay, so let's look at why. First of all, let's look at where we are now, way out to the right. As you can see, since about 2017, which is when about starting right about here, we went into La Nina. And we had a La Nina in 2017. It wasn't real severe, it was just a La Nina. But then we had a very weak El Nino. That El Nino is, look how weak it is. Doesn't even come up to a 1 on the scale. Compare it to the other El Ninos. Then, about the beginning of 2020, that's 2.5 years ago, we went into La Nina again. And this is a strong La Nina. And it's gotten stronger in the past year, really. When it started out, it was fairly strong. It was down below -1 on the index. And now look how far down it's gone. If you look at the El Nino of 2016, that was a strong El Nino. That gave us these conditions by early 17. Because El Nino spreads a lot of precipitation, especially over the south. So you don't get drought in California. This is why I have a little bit of problem with people saying it's the overall global warming that's causing the drought in the Southwest. I have trouble believing that because this was only 5 years ago. It's not like the planet's temperature has gone up much in 5 years. We are increasing. We're on a trend. But when I look at a dramatic change like that and that in 5 years, No, I don't believe that it's the global warming trend when I know La Nina tends to bring drought to the Southwest. I know El Nino tends to bring a lot of moisture to the Southwest. Go ahead.
I wonder sometimes, since we have a lot of people, more living in Texas and California, and we're growing more crops, etc. We're using the water table. Doesn't that also affect the drought?
It does. That's right. In other words, if you are tapping in to a water table like the Edwards Aquifer in Central Texas, and you're tapping into that groundwater and more people move in, they irrigate lawns, they do all kinds of things, and it'll cause that water table to drop. But we're also talking about sheer lack of rain. You know, there just hasn't been as much rain in those places. But Patrick, my argument is, if you look since about the end of 2016 to now, it's been almost all La Nina. In fact, look at the left-hand side of this graph from the late 70s up to the late 90s. Would you conclude that El Nino ruled the roost? Back then, El Nino, back in the 80s and 90s, most of it's red.
I would agree with that. Yeah, I would agree with that.
That's the El Nino was ruling the roost. But we've had turnabout now. Over the past 24 years or so, look at all the blue. And the El Ninos that we have had have been very abbreviated. Look how short and weak so many of them are in the 21st century. And look at La Ninas again, that's the blue. Cold water over the equatorial Pacific. And you see blue from about 98 or 99. That's nearly 25 years of a domination of La Nina. And so that's done two things. It's made the Southwest of the United States more vulnerable to drought, and it's caused the temperature trend in global average temperature it's still going up, but it's below trend. It's below the trend. And we're going to talk about that next time, because a lot of people are getting on here saying, oh, the trend in global warming is not as steep as it was in the 80s and 90s. Global warming is on hiatus. That's not true, because what this suggests is that if and when we go back into a period in which El Nino rules the roost, we're going to see an acceleration of global warming. And that's what we're going to talk about next time in part 3 of this series.
Hey, we're talking with Dr. Thomas Blaine. He's an associate professor with the Ohio State University Extension Program. Tom, it's always a pleasure. Learn a lot. And I really appreciate you going more in depth about La Nina, El Nino.
Thanks a lot for having me, Patrick. I always enjoy coming on and talking with you about Earth is our home.